Hi dear fellows, today we are going to learn about the stepping stone method. In the stepping stone method, what we do, we try to find out the initial basic solution from different transportation method like Vogel approximation method, least cost method, and other methods. So Vogel approximation method is the most appropriate one. So through Vogel approximation, we have found these allocations. What does that mean? It means the 5 units have to be supplied from the warehouse fund to the customer 1. 8 units have to be supplied from warehouse 2 to the customer 3. 7 units have to be supplied from the warehouse 3 to the customer 2. 2 units has to be supplied from the warehouse 4 to customer 1. 2 unit has to be supplied from warehouse 4 to customer 2. 10 units has to be supplied from the warehouse 4 to customer 3. Plus the supply and demand is equal. Now after this initial basic feasible solution, what we have to do, we have to find out the allocated cells. So you see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 6 are the allocated cells. So M is the number of rows. We have 1, 2, 3, 4. 4 rows we have. N is the number of column. 1, 2, 3. 3 is the column. So when we apply this formula, M plus N minus 1, we have reached to the number 6. So for the optimal solution, stepping stone or the Moody method, you have to see whether they are equal or not. If they are equal, then we may go for the stepping stone iteration method. So you see in this stepping stone method, what we have to do, we have to find out the unallocated cells. Unallocated cells, that whether this solution is optimal or not. Solution is these allocations are optimal or not. So for this process, what do? We try to find out the unallocated values one by one, that do we need any change in that or not. Okay, let's start with that. X 1, 2. 1 is the row, 2 is the column, 7 is the X12. So X12, we are going to find the values of X12, and if the values are negative, then we will have to recheck the iteration, re-evaluate the iteration, and re-evaluate the allocation. Because if the allocations are not correct, then we will get the negative value of this indexing. So for the indexing X12, you see what we will do. We will start with this 7. We will start with the 7, 3, 4, 1. So we need to see where are the allocated values. Allocated values over here. Allocated values over here, 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 here. So we need to make a loop of allocated values, starting from the unallocated values, and we have to go towards the allocated values. Okay, start with the 7. 7 to 4. No, we cannot go to 4 because it is unallocated. Okay, we may go to 2. Yes, we may go to 2. Okay, we go to 2. Then, is there any allocation? No. We will reach to the 1. Yes. Then we will reach to the 6. Yes. It is the nearest one. So we have to make the shortest loop. So this is the shortest loop we have found. You see, there is no other loop. If we go to the vertical way, yes, we can go, but we cannot make the loop over here. We cannot make the loop over here. So this is the shortest one. Start with the plus 7. Okay, so these are the per unit cost, per unit cost of supplying the goods from here to warehouse 1 to customer 2. Plus 7 minus 2 plus 1 minus 6 equals to. let me repeat, plus 7 minus 2 plus 1 minus 6. You see, alternatively plus minus plus minus. Now we have to add them up. 6 plus 2 minus 6 minus 2 minus 8 plus 7 plus 1, it is 0. It is not negative. So we don't have to worry about it. It is not negative. So we don't have to be worry about it at all. Now, you see, for the 4, one first column, first row, third column, starting with the 4. Okay, next the shortest loop we have 2 is the nearest one and 1 is the nearest one. Only we need to decide for which one is making a loop. It is not making any loop. It is not even at all. So we will have to ignore this one and we have to move towards here. You see, reach over here. So 4 to 2 we have to reach, and then 2 2 we have to ignore 6. Why? Because it is not shortest, as there is no other allocation over here. So we cannot reach directly to 4 again. So for that, yes, if we go to 1, we can directly reach to 2 and then 4. So we will go like this: plus 4 minus 2 minus 2, ignore 6 2, and then 1 minus 2. So let me repeat: plus 4, ignore this, minus 2, ignore this, plus 1, and then minus 2. So let's add them up. Minus 2 minus 2 minus 4 plus 4 0, so plus 1. So it is plus 1, so we don't have to worry about the allocation. Allocations are correct and there is no need of change. So these indexing is telling us that whether do we require any allocation in this in these elements or not. Over here, over here, over here, over here, over here. Okay, that's what we are doing. So you see, let's move ahead. X 2 1 plus 3, starting from the plus 3, then we may go to the horizontal or the vertical. If we go to the vertical, yes, we may go to the vertical, but is it making the loop? No, it is not making a loop. We cannot get back, so we cannot go to vertical. If we go to here, then are we going to make a loop? Let's see. 3 2 1, yes, we may go here. Making a loop? No, we are not making a loop. Okay, if we go to the 3, from the 3 to go to 1, then go to 2, then go to 1, yes, but we need to ignore 6. Why? Because 6 is not helping us in making a loop. So plus 3 minus 1 minus 1, ignoring 6, minus 2 plus 1, and it's making a loop. So minus 1 minus 2 minus 3 plus 1. So you see, there is no need of any kind of allocation in this cell. Now let's move ahead. X22. So in X22, that is plus 3. Okay, so can we make the shortest loop from here? Yes, we can make a shortest loop from here. We cannot go into the vertical in any way because we cannot get back. So this is the better one. Plus 3 minus 1 plus 2 minus 6, ignoring 4 and reaching to 3 again. Minus 6 minus 1 minus 7. So you see minus 1 is there. So this cell this cell has to be reallocated. We will be doing operation over there, but we need to complete the iteration. So again the unallocated cell is 5. So 5 is 3 1 plus 5 minus 4 plus 6 minus 1 plus 5 minus 4 plus 6 minus 1 minus 4 minus 1 minus 5 plus 5 plus 6. Now you see 7 is also unallocated, so we will check that out as well. 3 plus 7, shortest loop is there, plus 7 minus 2 plus 6 minus 4. So minus 4 minus 2 minus 6 plus 6 plus 7 would be. So you see over here, this is the only minus we have, so we have to do the operation so that we can reallocate. So we need to remember that what was our way. Our way was plus 3 x22 plus 3 minus 1 plus 2 minus 6. So you see, what was the minus? This one and this one was minus. This one and this one was minus. Okay, so minus 1 minus 6. So in the minus, we need to see which one is the smallest one value of the allocation. 2 is the smallest. So we have to reduce 2 from here, increase 2 over here, increase 2 over here. Let me write again for you. 2 7 4 3 1 5 4 7 1 6 2. You see, this was the matrix we had. Now we have to allocate, change the allocation. It was the previous allocation we had 5 2, it would be same, it would be remain same. 4 remain same, but the allocations would be here, would be changed. It will be 2, now it is 2. It is 6, it is 0, so we don't write 0. It is 8. It is 8 from 10, it is 8. Okay, from 0 it is 2, from 8 it was 6, from 2 it was 0. So we need to see whether they are equal or not, demand and supply are equal or not. Let's see that. Five, 8, 7, 10, 7, 9, 14. So you see 14 plus 9 is 13. 14 plus 9 is 23. Okay, 23 plus 7, 30. 5 plus 8 is 13. 13 plus 7 is 20. 20 plus 10 is 30. So you see demand and supply are same. So now we have reached to this, but this is not the optimal solution. Remember, this is not an optimal solution. For optimal solution, we need to do another iteration. Another iteration. An iteration has to be in the same way, So let me rub for you. so that we can do another iteration. As we remember, the initial cost was 80. The cost is keep changing. The initial basic feasible solution of Vogel approximation method cost we found 80. Now we are trying to optimize, so let's find out the cost again. So let's find out cost of this. So 5 into 2 plus 3 into 2 plus 1 into 6 plus 4 into 7 plus 1 into 2 plus 2 into 8. 1 2 3 4 1 2 3 4 5 6 1 2 3 4 5 6. So 6 is the total count of the allocated cells. So 5 to the 10. So 10 plus 6 plus 6 plus yes. So we are over here. 7 4 is a 28. 28 plus 2 plus 8 to 16. In total, what has it become? So you see over here that 68 is the lower cost than what we have found from the initial basic feasible solution with the Vogel approximation method. So you see 68 is the lesser than 80, that is $12 less than that. So let's make it more optimal with the towards optimal. It is not optimal because negative is the value over here. Now for the optimality, we have to do the iteration again, and in that you see iteration 2. In the iteration 2 x1 2 x1 3 x2 1 x3 1 x3 3 x4 2. Okay, x4 2 is 6. So this 6 is x4 2, 7 is x3 3. Since it is a third column, it is a third row and third column. So this is the row, this is the column, this is the row, this is the column. So we are in the first row. First row we have the 2 numbers. Second row we have the 1 only. In the third we have the 2, you see, and in the fourth we have the only 1. Okay, let's begin. Let me tell you again that what we are looking for. We are looking for that these allocated values of the quantity are optimal or not. Because if they are not optimal, then we may have to allocate the unallocated cells like 7 4 3 5 7 6. So that is what we are doing. And how would we get to know that they are there is a need of reallocation when we get the value of this indexing negative, like x12. Let's try to make a loop, shortest loop through a stepping stone method. In the stepping stone method, you have to step on the stones. Stones are the allocated values. The first stone is over here, you see, and the first stone is over here, and the shortest path cannot be this, shortest path cannot be this, shortest path cannot be this, so it will take a long way, you see. So in this column, if we go, we don't have any way to make a loop. If we go this way, we don't have any way to make a loop. If we go this way, we cannot go this way because there is nothing allocated over here. So the loop would be a big one, from like six values at least, not 4, 6. 3, we may have to go to 4 in the vertical way, and from here we will have to go to, from here we may have to go to, okay, let me write this, +7. Okay, so +7 and +7 -2, okay, +1 and +1 -2 +1 and -3. 1, 2, 3, 4, 5, 6. Let me show you the root again. +7 -2 +1 -2 +1 -3, and here we are. So let's make it total. -3 -2 -5 -7 +7, that is 0 +1 and +1 +2. So +2 is over here. +2 is over here. So we have the positive number. So there is no need of reallocation over here. So let's move to the second one. X +4. x13 +4. So let's make a short loop. No, we cannot. Yes, we have the far. You have to go to the far, ignoring the 1, reaching to the 2, then 1, then 2, then get back to 4 again. +4 -2 +1 -2, then get back to 4 again. So -2 -2 -4 +4 +1 is remaining. So it is also plus. So there is no reallocation in this loop, in this whole loop, in this and that, in this. Okay, let's move ahead with the 3. X21 is 3. So 3 shortest loop with the horizontal. No. Then yes. So we have to ignore this one and jump to the 1. That will be -1 +2. Jump to the 1 next stone. Remember that will be always alternate. +3 -1 +2 -1. -1 -1 -2 +2. So +3 is the answer. So since it is plus, so we will not reallocate any of this loop, any cell of this loop. X31 is over here. +5, you see +5. So plus 5, when we start with the plus 5, so what is the shortest loop? If you go to the 4, horizontal way, 4, so then vertical, okay, then horizontal, no, it is not. There is nothing to step on. There is no allocation. Okay, so then the loop has to be big one. Loop has to be big one. Okay, so with the plus 5, you will go to the 1, minus 1, then plus 2, okay, then plus 2, then minus 1, then plus 3, then minus 4, and here we are. So 1, 2, 3, 4, 5, 6. So it's a big one. Minus 4, minus 2, minus 6. Okay. Plus 5, plus 2, plus 6. So plus 6, minus 6, plus 3 is there. So plus 3 is remaining. Oh, it's again the positive one. So there is no need of optimality. So we are going. There is no need of any reallocation. Okay, x33 is 7, third row, third column, 7 plus 7 plus 7, we have to make a loop, plus 7 minus 1 plus 3 minus 4, and here we are. Plus 7 plus 3 plus 10 minus 4 minus 1 minus 5, so it is plus 5. So you see plus is again, positive is again. The last is the 6 we have, plus 6, 4 2, 4 2, 4 2, fourth row and second column 6. So let's make a loop, shortest loop, plus 6 minus 2 plus 1 minus 3 and 4, ignore, and I get back again, plus 6 minus 2 plus 1 minus 3. Okay, so you see, let me tell you again, plus 6 minus 2 plus 1 minus 3, ignoring 4, get back again. This is the shortest loop we have. Okay, so plus 6 plus 1 plus 7 minus 3 minus 2 minus 5, so plus 2. So you see all of the numbers are in positive. So this is the optimal solution. The initial basic feasible solution cost was, with the Vogel approximation method, cost was 80. After the optimality with the stepping stone method, we have reached to the 68, and this is the final answer. Thank you.